Now we're going to look at graphing circles using polar equations. We've done circles, obviously, when we've done rectangular coordinates or Cartesian coordinates. You know, the x squared plus y squared equals r squared. But in this next section of things, this is going to introduce the next section. We're also going to talk about the 5 classic polar curves. Now this video is going to focus on the circles, though. So in the videos to come, following this one, we'll see cardioids, limicons, lemniscates, Rose curves, and the Archimedes spirals. So we'll briefly touch on the polar formulas for the circle. That's what we're going to do now before moving on. So in a circle, this is from the book. Some of the formulas that produce the graph of the circle and polar coordinates are given by r equals a cosine theta and r equals a sine theta, where a is the diameter of the circle, or distance from the pole to the farthest point from the on the circumference. The radius is absolute value of a over 2, or 1/2 the diameter. R equals a cosine theta. For that one, the center is going to be at a over 2 comma 0. And for r equals a sine theta, the center is at a over 2 comma pi. So here are the graphs that you might expect with this. So in the case that a is positive and it's the r equals a cosine theta, you'll see the circle over here on the right side. For r equals a cosine theta and a is negative, you see it on the left side. For r equals a sine theta and a is positive, you see it up top. And r equals a sine theta and a is negative, you see it down below. So we're going to graph r equals 4 cosine theta. And so you can almost guess what it's going to be, because 4 is that diameter. So we're looking at starting here, going out 1, 2, 3, 4. So it should go out this far. Let's go ahead and use the standard values. Now I will go with our theta and r equals 4 cosine theta. Maybe I should do this in steps. I think I will. I'm going to do this as cosine theta, and then r equals 4 times cosine theta. So I'm going to go with 0, pi, using our graph, pi over 3, no, pi over 6, excuse me, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, and then I usually go one further just to make sure it's going to overlap, 7 pi over 6, which this will. So cosine of 0 is 1. Cosine of pi over 6 is the square root of 3 over 2. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. We have negative 1/2 for cosine of 2 pi over 3. Negative square root of 3 over 2 for cosine of 5 pi over 6. Negative 1 for pi. And negative square root of 3 over 2 for 7 pi over 6. Now we multiply these by 4. So 4 times 1 is 4. This would be 4 times the square root of 3 over 2 is 2 root 3, which is approximately 3.46. 2 times 1/2, 4 times 1/2 is 2. Four times 0 is 0. And we have our 4 times negative 1/2 is negative 2. 4 times negative square root of 3 over 2, it's going to be negative 2 root 2, which will be approximately negative 3.46. 4 times negative 1 is negative 4. And then 4 times negative square root of 3 over 2, we just saw that, is negative 2 root 2, which is going to be approximately negative 3.46. I'll come over here and graph it. When we're on this axis here, it's going to be at 4, so we're at 1, 2, 3, 4. And then at pi over 6, we're going to be at 3.46. So 1, 2, 3, 4 is there, so we're just a little less than half there. Then at pi over 3, we're at 1/2, or sorry, we're at 2. So pi over 3, we're at 2. And then at pi over 2, we're at 0. Then we're at this one here, 2 pi over 3, but we're at a negative, so we're down this way at negative 2. Then for 5 pi over 6, we're at negative 3.46, so right about there. And then we're back to negative 4. Then if I go to 7 pi over 6, we're at negative 3.46, so we're back there again. So this does work out. So we have this circle shape that works out pretty well, like that. And you can always check it on Desmos. Now, one thing I'll say, this graph doesn't, the one I found here, didn't have the pi over 4 there. So you could always add the pi over 4 in and graph that as well. But there you go.